Hi, welcome back to McClutchy Maths. My name is Natalie McClutchy and today we are looking at our fifth video in our Advanced Algebraic Techniques playlist. This is a video on solving linear inequalities. Okay, so this is aimed at our students in grades 10 and up. If you are in the UK though, this is covered in Key Stage 3. Now firstly, let's talk a little bit about our greater than and less than symbols. So far we've only been dealing with linear equations and equal signs and situations where one side of the equation is equal to the other. However, in this video we're going to be looking at where one side of an equation is greater than or less than the other side of the equation. Now you might be familiar with some of these symbols from primary school or junior high school. So these are our symbols here, this one here, less than or equal to, greater than or equal to. Now, I'm going to talk a little bit in a moment about ways that you can remember what those symbols mean. It makes a lot more sense though when you've got numbers on either side. What these symbols do is recognize something that is unequal or inequalities. One side of that sign is bigger than or smaller than the other side. You would also be familiar with this using numbers. So if I put a 3 and a 5 between one of these symbols, what this is saying is that 3 is less than 5. Now we know that intuitively, but how would you know what this symbol means? Okay, so one of the ways I've had students explain that to me that they've learned in primary school is that that's a crocodile's mouth. You think of the mouth of the crocodile, it's wide open. The crocodile always faces his mouth towards the bigger feed. So in this case, 5 is the bigger number. And so he is facing his mouth towards the bigger number. Another way of thinking about that is that the arrowhead, these could be considered arrowheads, that the arrow always points to the smaller feed or the smaller number. So if you're thinking of arrows, you're going for the smallest target. Whatever way you choose to remember it, that's up to you. However your teacher taught you, go with that. But just remembering what this actually means here. Okay, and as we've just mentioned, that arrowhead is going to point to the smaller quantity or the crocodile's mouth to the bigger quantity. Now we can do this bringing in some algebra, and this is where it gets a little bit more complex because one side is going to be a letter, the other side will be a number. In here, what I've actually done is I've used two different letters, and what this means is that because the arrow is pointing to the smaller quantity, then A is less than or equal to B. Okay, so this extra little symbol under here means or equal to. It could be less than or equal to. So if, for example, B we knew was the number 10, then that means A could be all of the numbers that are less than 10. It could also be equal to 10. Now we can also graph inequalities very simply on a number line. So here is what a number line looks like. It's going to stretch into infinity on either side. So if I have, for example, and I want to represent every value that's more than 1, what I'm going to do is I'm going to draw a line above the number line that's going to look like this. So you'll notice that it doesn't quite start on the number 1, and that's because we need a little symbol here to explain something else, which I'm going to get into in a moment. But basically we want this arrow, it's all values greater than the number 1, so it's going to stretch into infinity, pointing towards the bigger numbers. That's an easy part. Now, I need to tell people whether 1 is included in that or not. In this situation above, I'm talking about all the numbers greater than 1, but not including 1. So the way that I do that is I draw an open circle, and that's why the line doesn't go exactly above the 1. The circle goes exactly above the 1, and then that line stretches out into infinity after the 1. And so that's an open circle, indicates don't include 1 in that. So 1.00001 is included, but 1.0 is not. Now, if I wanted to write this using algebra, I would write this as all the values of x, because typically when we have a number lines are typically on a Cartesian plane, that's our x-axis. So we would write that as x, all values of x are greater than 1. We don't have to use x as simple. You said here I could write this. It's not I must write this, because if you're given a different variable for this number line, all values of m or all values of g, depending on the context, then it'll be simply all values are greater than 1. 1 is the smallest possible answer. but it's not going to include 1. Now, if I wanted to include 1, so it was all values greater than 1 and including 1, I'm going to colour that circle in. So you'll notice it's coloured in there. So coloured in means I'm including 1. Open circle with no colouring in means not 1 included. Now, I would be writing that like this. X is greater than or equal to 1. Now, students often want to know a way to remember that. How do I remember whether it's just a circle or whether it's a coloured in circle? The way I remember it is that if the circle is coloured in, it takes me a little bit more work to colour that in. There's a bit more effort there. There's also a bit more effort to write greater than or equal to. If I don't colour in the circle, it takes me less time. If I don't put that little equal to sign underneath, it takes me less time. That's the way I remember it. You might have a better way of remembering it, and if you do, why not tell us in the comments? Okay, I also can use this technique of open circles, closed circles to show ranges of values. For example, let's say I had a real life situation where I wanted to communicate using a number line that a preschool can cater for ages 0 and up to, but not including 5-year-olds. Because once they turn 5, they're supposed to go to school. So the way I would show that on the number line, well, firstly with algebra, I start with the smallest number on the left-hand side, and all the values of x are going to be greater than or equal to 0. So I could have a newborn baby come into my preschool, and all the values then are going to be up to, but not including 5. And on the number line, that will look like this. Closed circle coloured in, from 0 all the way up to, and then an open circle here. So you can see it's what's called an interval. It doesn't stretch into infinity on each side, mainly because I can't have negatively aged children, and I don't want children more than 5 in my preschool. So I've got, it looks like a bit of a barbell, I guess, 2 circles on either side with a line in between. And we typically draw that above our number line. Not way, way, way above it, just above it. Okay, now we've been talking in the beginning of this video about how to solve equations which are no longer equations. They're called inequalities. We've been doing that with equal signs in our previous video. We're now going to do those solvings with those other symbols, the greater than, the less than, etc. Now we've got only one important rule, because basically we're just going to solve these equations, which are not equations anymore, they're inequalities, as though they were equations. However, there's only one important rule you must remember, and this is different to solving linear equations, is that when we divide or multiply both sides of the inequality by a negative number, the inequality symbol must change directions. So if it was starting out as a greater than symbol, if we divide both sides by, say, -5, it's got to flip directions and become a less than symbol. So this symbol here will become this symbol here, and less than equal to becomes greater than equal to when we use negative multiplication and division. If we don't use negative multiplication and division, the sign stays the same as it does at the beginning of the question. So we're going to do a series of worked examples in a moment. It's always a good idea when you get to the end to test your inequality to make sure that the inequality is true. I'm going to show you how to do that with each of mine. I'm also going to show you some more of the graphing with each of these examples as well. So here's worked example 1. We're going to solve and graph 3n plus 4 is greater than 13. Okay, so we're going to treat that greater than sign as though it's an equal sign. Just like normally solving equations, whatever we do to one side, we've got to do to the other side. So let's write that out underneath a little bit bigger. And what I'm going to do, if this was an equal sign in the middle, I'd be subtracting 4 from both sides. Now, subtraction from both sides of a negative number does not change the sign. Remember, it's only multiplication and division. I'm not multiplying both sides by -4. I'm not dividing both sides by -4. I'm just simply subtracting 4 from both sides. So now it's going to give me 3m is greater than 9. So I'm going to divide both sides now by 3, and it's a positive division, so no change of the sign there. The answer is m is greater than 3. Now here is where I should check my work. Always a good idea. So what I'm going to do is substitution. Now normally if I was solving an equation, I would simply be putting 3 back into here. 3 times 3 makes 9 plus 4 makes 13. And if it was an equation, it would be 13 equals 13, and I know I've done it right. However, it's a little bit different with inequalities because 13 is not greater than 13. 13 is 13. So what I'm actually going to do is my solution says I've got to have a number bigger than 3. So I'm simply going to pick a number that's bigger than 3. Let's choose the number 4. It's the next easiest one. So we're going to substitute a bigger number than 3 into the equation and then see if it holds true. So 3 times 4 makes 12, plus 4 makes 16. 16 is greater than 13. Therefore, that's true. So therefore, I have solved this side correctly. So what I'm doing over here is just simply a test, just to make sure that my sign is pointing in the same direction. This is a good way to get around having to memorize that rule, although it's a good idea to memorize it. But if you're not sure, oh, should I have changed the sign this way or that way? This is a good way to test that at the end. Okay, now I've got to graph this on a number line. All values greater than 3. So I'm going to start at the 3 with my arrow, pointing on to all the greater than numbers. And this is where it's a good idea again, just to test you've done it in the right direction, because you might be thinking, oh, I can't remember where the crocodile mouth points to. Okay, so I've got a number which is greater than 3 is 4. If I put the 4 here, is 4 bigger than 3? Yes, it is. So it should be pointing towards all the bigger numbers. And it's not coloured in because this has not got the equal sign underneath. All right, worked example 2. Now slightly more difficult because we are in Year 10 after all. We are doing more difficult things. We've got a fraction in here now. So what I'm going to do first is simply treat that like that less than equals to sign is an equal sign. And I'm just going to follow my normal rules. So the first thing I'm going to do is I'm going to subtract 4 from both sides. It's tempting to try and get rid of the fraction first, but if I do that, I've got to remember to times everything by 3. Not going to do that just yet. Let's just subtract 4 from both sides. So what I get is negative j over 3 is less than or equal to the number 2. Now I'm going to get rid of this division, but I need to remember this is a negative. So I'm actually going to be doing the opposite of divide, which is multiply, and I'm going to be multiplying both sides by negative 3. And this is where my sign flip over rule takes place, because now I've multiplied both sides by a negative number. So now my answer will be j will be greater than or equal to negative 6. Now here is where the checking is critical, because you might not be 100% sure. You might have forgotten to flip your sign around. You might not be 100% sure if you should have or if you shouldn't have. So here's where you're going to check. Think of a number that's bigger than negative 6. Now, anytime you can use the number 0, I always say use 0. 0 is bigger than negative 6, and it's an easy number, especially with fractions, to substitute in. So we're going to substitute j equals 0 into this equation. Now, when I substitute j equals 0 in, that means that's going to become a 0. Anytime you've got a 0 as part of a fraction, the whole fraction will just become 0. So I'm going to have 4 take away nothing. So 4 take away nothing, is that smaller than or equal to, because remember this was my original equation, 6. Yes, it is. So 4 is smaller than 6, so yes, it's true. Now you might be thinking, but hang on a minute, that's flipped over here. What we're simply doing, if you wrap your head around this, is we started with this as our answer. We thought of a number that was bigger than that. We've substituted into the original equation, and it's worked out true. So because it's worked out true by substituting 0 in, that means our working here is correct. However, if we'd forgotten to flip it down, we couldn't have used 0, because 0 would not be smaller than negative 6. So we would have had to use something like negative 10. And then once we do that, we would find that it doesn't work, in which case then we know our sign is in the wrong direction. So because we've substituted something that is true over here and it's now true over here, we know we've got it right. Okay, let's graph that on the number line now. All values more than negative 6. So let's find negative 6 on the number line first. It's over here. And this is where people get a little bit confused with their negative numbers. Numbers that are bigger than negative 6 are all over this side of the situation, and we're going to colour that dot in because we've got this greater than and equal to symbol, and all the values into infinity that are more than negative 6 get graphed. Okay, this time we've got terms on both sides of the inequality sign, 3k and a 6k. So we've got some variables there that we need to collect first. So we're going to just simply follow the process as though we would for normal solving equations. Let's take 3k from both sides. We're left with 2 is greater than 3k take away 4. Now we're going to take the negative 4 to the other side by adding it to both sides. And the sign doesn't change because we're not dividing or multiplying by a negative number. Okay, now we're going to divide both sides by 3, and it's positive, so we're not going to change the sign again. We're left with 2 is greater than k. We could also, typically with algebra techniques, we typically start with our variable and then we write our answer afterwards. So we just simply flip that around. K, if you remember here, 2 was the biggest, k was smaller. So all values of k are smaller than 2. And that's how we would write that. Now, you might be thinking, oh, I'm not sure if I did that right. Did I follow the rules correctly? I wasn't dividing by a negative number. Why have I swapped that around? You might be overthinking yourself. So this is where you've got to check. Now, the solution's saying that k must be less than 2. And as we saw in worked example 2, working with 0 is really easy to work with for substitution. So we're going to use k equals 0 and substitute that back into our original equation. Okay, so this is going to become 0. This is going to become 0. So our answer will be 0 plus 2. Is that greater than negative 4? Well, yes, we know that 2 is greater than negative 4. It's true. So because we've got a true answer here, we know we've solved it correctly. So let's draw that on the number line. All values must be smaller than positive 2. So there's our line there, not coloured in because it's not an equal to symbol as well there. So it's just all those values there. Okay, our last example today, we are looking at some fractions on each side. This is a bit bleh. Okay, so we're just going to treat it as though they were fractions with an equal sign. So we're going to follow our principles that we've been looking at in our advanced algebraic techniques in our previous videos. We're going to multiply both sides by 6. This is what we call cross multiplication. We went into that in a couple of our previous videos. Go and watch those if you're not sure. Okay, so what we're going to end up with here is 6, and we're going to put some brackets around our numerators. And now 6 divided by 2 becomes 3. 6 divided by 3 becomes 2. And everything else hasn't changed. Okay, so I've still got our values in brackets. Now we need to expand the brackets out. So we're going to have 3 plus 3y on the left-hand side and 2y take away 2 on the right-hand side. Now we've got some like terms that we need to collect, and we always bring our smallest coefficients of y to the side with the bigger coefficients. So we're going to subtract 2y from both sides. Let's take this up to the right-hand side here so we can have a look at it a little bit easier. So we're left with 3 plus a single y is less than negative 2. Now let's subtract 3 from both sides, and we end up with y is less than negative 5. Now we're going to do our checking technique here. Now, this is where it gets a little bit tricky because I need to think of a number that's smaller than negative 5 that I can substitute into here. And when I do that, I'm going to get the right answer. But the problem is that these are fractions, and it's going to be really yucky. So what I'm going to do is, I know that if I substitute 0 in there, it's going to be easy for me to work with. We've seen that in the last 2 examples. And I like working with zeros when I'm dealing with fractions. However, we know that 0 is not smaller than negative 5. So when I get my answer, the answer needs to be false if this sign is in the right direction. Because I'm putting in a falsehood and substituting a falsehood in. 0 is not less than negative 5. So when I substitute in 0, the answer is going to be false. That's what I'm looking for. Now, you might want to pause there and have a think about there. If I was to put something in and get a true answer, I'd be putting in something like negative 6. Negative 6, like I said, going to be yuck to work with. You can try it if you wish. Going to be difficult though. Let's put in something easy. Put in 0 and look for a false answer. A false answer tells me I've got my sign in the right direction. Okay. So 1 plus 0 over 2, 0 take away 1 over 3 becomes a half is smaller than a negative third. Now, I don't even have to think about whether a half is smaller or bigger than a third. I just know a positive number is not smaller than a negative number. The answer is false, which is what I was hoping for, a false answer in this case, because a false answer tells me I've got the right solution here. And let's graph that now. So let's find negative 5, and all the numbers that are smaller than negative 5 are part of my graph. Well, hopefully in this video you've seen some techniques that are helpful. Maybe it's simply just solidifying for you what greater than, less than means. Maybe some of those techniques and the checking techniques that I've used are helpful as well. Might be worth, if you got a little bit lost with anything there, just to go back and pause and just reflect and think about what you've seen. If you did find something in this video helpful, you can engage with us further by liking and subscribing and hitting that notification bell so you'll always know when the next video is available. You could also tell someone about this video. Why not share it on your OneNote page or show it with a family member or a friend? You can also follow us on social media, tips, tricks, competitions, memes, it's all there on Facebook and Instagram. If you've got any questions at all, mcclutchymass@yahoo.com is the place to reach me with the difficult questions. You might even have an inequality that you've worked on and you couldn't get it right, you don't know what you've done wrong, you might want to have a fresh set of eyes look at that for you. Well, I'm here to help. Well, thank you so much for watching today. My name's Natalie McClutchy and you've been watching McClutchy Maths. Have a wonderful day.